let's see, question 1. So we have this is an alkyne. So we have an ethyne, so a C triple bond C. And then what it's going to do is going to, so the first step here is reacting with sodium amide. And the second step is I'm also reacting it with, this is CH3C2Br. So this is brom, some type of alkyl halide, and then there's one equivalent of that. And what do I get? So the first step here, if I have an alkyne, what this is going to do, so let me just do the first step here actually. So what it's going to do, it's going to reduce this alkyne into a, it's going to become a nucleophile, right? And how it does that is that we have, let's see, we have, this is the positive charge on the Na, and the negative charge on the H here, on the NH2 here. And what it's going to do, it's going to actually, like, you know that this is associated to Na plus and NH2 minus. And what we have here is we have, this is, remember my carbon here, the carbon hydrogen, this triple bond here is electron rich. So what it's going to do, it's going to pull an electron density away from this hydrogen, right? So again, we have this here is negatively charged here because we have that triple bond, and then we know that this here is, I'm going to say it's partial. Actually, no, I'll just say negative, it's fine. This here is this here would be positive here. This here is negative. So what it's going to do, this NH2 is going to come here and take this hydrogen away, and it's going to basically deprotonate this alkyne here. So what we're going to get is we're going to get something like this. So we're going to get H bond C, triple bond C, and then we have a negative charge on my carbon here. So this here, extremely potent nucleophile, and then what it's going to do is going to react with the step 2. Right? Step 2 is this, I'm adding CH3, CH2Br, and what it's going to do is going to attach to this, negative charge here. So it's going to attack basically on this side because again the Br here is negatively charged, which means this side is positively charged here. So what it's going to do, it's going to come into here and take this away. So what it's going to do, and now my compound I'm going to get here is I have H, I still have my C triple bond C bond, and then I have what, CH2, and then I'm going to have another CH2. Sorry, I don't have space here. I'm going to have CH2, CH2, it's a 3-chain CH2, and then Br here. So this here is an alkylation reaction, right? Again, I have some type of, I'm bonding carbon bonds here. So this here is bonded like this. Again, this negative charge takes away one of these hydrogens here. So that's good for this question. It's only one equivalent, so it doesn't break this triple bond here. So what's going to, after it's going to undergo hydrogenation reaction, right? So this Lindlar's catalyst with hydrogenation. So this is H2, Lindlar's catalyst. So what it's going to do, it's going to reduce, it's going to hydrogenate this triple bond here. So I'm going to get H bond C instead of a triple bond. I'm going to get now a double bond, and then CH2, 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 sorry, this is CH here, CH2, Br here. And then finally what's going to happen is that I'm going to then draw out my, it's going to react with H2O, water, and also acid work up here, H2O plus. So what it's going to do now is that I have here, this is my first carbon, 1, 2, 3, 4. Wait, am I missing a carbon? 1, 2, 3, 4, 5, 1, 2, 3, 4. I am. Sorry, my bad. This is CH2 here. This is CH2 here. This is a Br here. Perfect. And then what I'm going to do now is, what it does is it's going to reduce. I have H2O here and an H3O plus. Again, it's going to then I'm going to what this does is going to it's a nucleophilic attack on this double bond here, and this OH is going to substitute right over. It's going to be bonded to the highly substituted carbon here. So in this case, it would be this carbon here. So it's this OH is going to bond to this carbon here, and then the acid workup is going to simply just provide hydrogen protons to this and stabilize this compound here. So let me see what solution they have here, and then it's going to make basically this compound. So let me just look at this here. It's kind of blurry, but NH2 makes this is H triple bond C bond C2 bond NABR here. NAB. Oh yes, that's NABR. So yes, that's actually sorry, that's my fault. There's no Br here. That's my bad. This is a CH3 compound. I forgot that. I didn't account for the sodium here, so that's my fault actually. This is CH3, and this Br here actually bonds with the Na here, because if you remember the first step, I split Na plus and NH2 minus here. The bromine here is going to this bromine has a negative charge here, and what it's going to do is going to bond with this positive charge here. So I get A plus NABR. So that's totally my fault. I forgot to account for this bromine here. My bad. Which means I just simply have this compound here. I don't have the bromine anymore. So what this does is simply it's just an SN2 reaction, right? So I have H bond and then C, H and then bond, and this double bond is going to break, and then I'm going to get C, and this is OH here, bond CH2. Oh, sorry. There's a H here, I believe. This is CH2 and CH3, or CH2 and bond CH3. And this here will be my answer, like this, right? I have CH3, like this. This here you can redraw as like CH3 or H3C. So I have 5 triple 1, 2, 3, 4, 5. That's good. 1, 2, 3, 4, 5. And there's OH that bonds into the second carbon here. So this solution here is correct. The solution is correct because they drew it out. They drew it out correctly here. They didn't provide the mechanism, but it's totally fine. But this here, the solution is correct. Again, what I had first was I deprotonated the alkyne with any sodium amide, and then this is going to bond with the propyl group here, and then it's going to form this long chain of 5 carbons with NABR as a side product. Remember, the bromine here falls off and bonds with the Na plus. Na plus and Br are ionic compounds. Right? This is just a side product. The alkyne is then hydrogenated with the Linder's catalyst to form an alkene. So that's formed over here. The alkene here. I don't know if you were supposed to show stereochemistry. In this case, I believe I don't think so because it doesn't really affected here, but they showed stereochemistry. So actually, I like their solution better than mine here. And what they did was they realized that this is it's a cis. Linder's catalyst reduces as a cis alkene. So basically, the CH2, the propyl group here, and the H here is on the same side. Again, it's just it doesn't really matter because I think all the groups here are H's. So it does. I don't really have a particular isomer that I'm looking at, but again, it is cis, and then I'm going to add H2O with the acid workup to make the nucleophilic attack. And this actually, they even show stereochemistry here, which is nice. So maybe I'll do that as well. And remember, this is going to add, it's going to be towards us as well. So this here is towards us here. Again, I'm not sure if they asked to show stereochemistry for this question, but oh, they did. It says indicate stereochemistry when applicable. Yes, okay, they did. So then I have to do. So this here would have been a cis alkene here. So let me redraw that. I did not read the question clearly. This is H3C. This will be a double bond here, and then I'm gonna get. Let's see. Basically the same thing as what I get is I get this compound here, right? I get this carbon. This is bond H, and this here is the double bond C. This here is bond H as well. This is bond H, and this here is the propyl group here, CH2, and CH3. So this here is our isomer or cis here because it's on the same side of our yellow bond. And then what it does is with the acid workup, with H2O and with water and with an acid workup, it's going to create a hydroxyl group that sticks outside. It sticks towards, sorry, not outside, it sticks towards, it's going to heading toward the plane here. So that's how we show stereochemistry into this question here. So the solution here is correct. So great solution and step-by-step process.